This is the Chapter 9 Notes video part 2. So at the top of page 5, it says constructed a confidence interval for the difference of two independent means with a graphing calculator. And again, we're using a TI-83 or 84 graphing calculator. So the first step is to go to stat test down to 2SAMP int, since this is using confidence intervals. If the data is raw, you're going to input the data into L1 and L2 and set the frequencies both equal to 1. If summary statistics are known, then you need to enter in those values for the mean and the standard deviation and the sample size for each of them. Set pooled to no, and then select your confidence level. And again, as a reminder, your confidence intervals need to be set up as a two-tailed test. Once you get your interval, you need to look and determine if 0 is in the interval or if it's not in the interval. So the example right below that we have says, assume the populations are normally distributed. And this one, no context given with this. It's just kind of learning how to work through this on our graphing calculator. So you'll notice we have population 1 and population 2. So this is our alternative hypothesis. It does tell us alpha is the significance level of 0.05 and with the given samples. So first thing that we need to do is construct our hypotheses. So our null hypothesis and our alternative hypothesis, it did give us the alternative, and that's saying that mu1 is not equal to mu2. And so your null hypothesis is going to be identical, except for, remember, that always has an equal sign. So mu1 is equal to mu2. So for this, we're going to go to 2SAMP t-test. On the graphing calculator, you need to go to stat, test, and then go down to 2SAMP t-test. From 2SAMP t-test, you need to enter in the mean for the sample, the standard deviation for the sample, and the sample size for both populations. And then once you have that, also select your alternative hypothesis, which is not equal. From the graphing calculator, we got a p-value, rounding that 4 decimal places, of 0.0175. And we need to compare this to alpha. And again, alpha is given up above as 0.05. So this is definitely less than alpha, which is 0.05. And this means that we are going to reject H0. So from here, we need to write a conclusion. Again, not much context with this. So we're just going to do the best we can on our conclusion. But again, with more word problems, we need to make sure that we're talking about that word problem specifically in that conclusion. So there is sufficient evidence at the alpha equals 0.05 level of significance to conclude that the population means are different. Part B, which is right below, says to construct a confidence interval appropriate for the hypothesis test that was done in part A. So first thing that we're going to do is draw our bell-shaped curve, our normal curve. And this time you will notice that we have a two-tailed test with that not equals to symbol in our H1. So that means that we're going to have two tails here. And in each of these tails is going to be alpha divided by 2. And so we know what alpha is. Alpha was given to us as 0.05, and dividing that by 2, we get 0.025. That's going to go in each of these tails. Again, that total area under the curve is equal to 1, so subtracting those little tails out, we will get a confidence level equal to 0.95. And again, this is our C level. On your graphing calculator, you need to go to stat, test, go down to 2SAMP int. From here, you need to enter in all your information. Your C level needs to be 0.95. And then you also need to make sure that you have pooled selected to no. And so for this, we get a lower bound and an upper bound that are given. From the graphing calculator, we get a confidence interval of 1.298 as our lower bound and 12.702 as our upper. And so with this confidence interval, you'll notice that 0 is not in the interval. And this means that we are going to reject each knot. So at the top of the next page, we have another example. This time it's a little bit more wordier. So it says researchers from the University of British Columbia conduct a study to investigate the effects of color on cognitive tasks. Words are displayed on a computer screen with the background colors of either red or blue. And it says results from these scores on a test word recall are given below. Higher scores correspond to a greater word recall. So we have red backgrounds and we have blue backgrounds. Part A says to use a 0.05 significance level to test the claim that the samples are from populations with the same mean. Assume the criteria for the test has all been met. So again, it does say for the same mean. So when we construct our hypotheses, our null and our alternative, our null is going to be that those two means are equal to each other, and our alternative would be that they are not equal to, since it does not state specifically less than or greater than in this problem. And also note up above that we are given red and blue, and I used ones and twos, so you need to make sure you identify what one is. So I'm going to let 1 equal red and 2 equal blue backgrounds. So in order to find our p-value, we do need to go to 2SAMP t-test. On your graphing calculator, you're going to go to Stats, Test, to 2SAMP t-test. From here, you're going to enter in all the information that's given to you in the table. Double check to make sure your numbers are entered in correctly. Also, make sure you select the correct alternative hypothesis, which is not equals to, and you've pooled set to no. From the graphing calculator, we get a p-value equal to 0.0101. And then comparing this to alpha, you'll note that alpha is 0.05. So this is less than alpha, which is 0.05. And since it's less than, this means that we are going to reject H naught, so reject our null. And then from here, we need to write our conclusion, again, discussing the problem. So this is going to start off with, there is sufficient evidence at the alpha equals 0.05 level of significance to conclude that the mean number of words recalled is different for red and blue backgrounds. Part B says to construct a confidence interval for the same test that we were doing in part A. So again, we're going to draw our normal curve. Look at what H1 is, and you'll notice that H1 again is a two-tailed test. So I'm going to go ahead and split off both of these tails. And again, whenever you have a two-tailed test, it's not alpha just going in one of the tails, it's alpha divided by 2 going in each of these tails. And so our alpha in this problem is 0.05. Dividing by 2, I get 0.025 in each of these tails. And that means our C level that we would have, again, you get that by doing 1 minus each of those tails, and we get 0.95. On your graphing calculator, you're going to go to Stat, Test, and then 2SAMP t int. From here, you need to enter in all of the data that you have. Select your confidence level, which should be 0.95. And then from here, you should get an upper and a lower bound. From the graphing calculator, we get a confidence interval of 0.882 for our lower bound and our upper bound of 6.278. And so looking at this and determining zeros in here, since they're both positive, this means that 0 is not in the interval. And this means that we reject H naught, which matches what we found in part A. The example right below says researchers wanted to determine if carpeted rooms contain more bacteria than non-carpeted rooms. To determine the number of bacteria in a room, researchers pumped air from the room over a petri dish at the rate of 1 cubic foot per minute for 8 carpeted rooms and 8 uncarpeted rooms. Colonies of bacteria were allowed to form in the 16 petri dishes. The results are presented in the table. The data is approximately normally distributed, and the question is, do carpeted rooms have more bacteria than uncarpeted rooms at an alpha equals 0.05 level of significance? So the first thing is that we have two different groups here. And so I'm going to go ahead and call group 1 carpeted rooms, and I'll call group 2 uncarpeted rooms. You also could use words or letters instead of just numbers, but setting up our null and alternative hypotheses. Your null is always going to be that the means are going to be equal to one another. Since this is asking about the number of bacteria that are in a room, we know that we are using means. And then for H1, it says that do carpeted rooms have more bacteria than uncarpeted rooms? So mu sub 1 is greater than mu sub 2. Before we actually conduct our test, we need to input in our data into L1 and L2. Once we have all the data in, then we can go to 2SAMP t-test. On your graphing calculator, you're going to go to Stat, Edit, and first enter in all your numbers into L1 and then into L2. Again, L1 is your carpeted rooms, L2 is your uncarpeted rooms. Once you have that, I'm going to go to Stat again, go to Test, go to 2SAMP t-test, and from here you need to make sure that you have data selected. And again, your frequencies should be set for 1 for both L1 and L2. Make sure you have pooled set to no, and then also make sure your alternative hypothesis is the greater than symbol, since carpeted rooms they're testing to see that carpeted rooms have more bacteria than uncarpeted rooms. From the graphing calculator, we got a p-value equal to 0.1780, and this is greater than alpha, which is 0.05. And whenever the p-value is greater than alpha, this means that we do not reject our null. So from here, we do need to write our conclusion. So we're going to start off with there is not sufficient evidence at the alpha equals 0.05 level of significance to conclude that carpeted rooms have more bacteria than uncarpeted rooms. At the top of the next page is section 9.3, two dependent samples. These are going to be matched pairs. So this is going to be our dependent versus 9.2, which is independent. So it says inferences on matched pairs data is very similar to inferences regarding the population mean. So here's our directions with using a graphing calculator. So testing hypothesis on the difference of two dependent means, or that matched pairs data, we need to check the requirements first. And the requirements that we have are that both are simple random samples. Sample data needs to be dependent, or that matched pairs. And the differences are normally distributed with no outliers, or the sample size is large, meaning that it is greater than 30 for both sets of data. Then step 1 is to determine the null and the alternative hypotheses. And so we have two-tailed, left-tailed, right-tailed test. You'll notice that this time we have mu sub d. And so the hypothesis is going to be constructed one of the ways, with mu sub d of the population mean being the difference between those matched pairs data. Difference again means to subtract. So mu sub d is equal to 0 for our null, and then our alternative again depends on if it's a two-tailed, left-tailed, or right-tailed test. So then we're going to select alpha, our level that we have, which is usually given to us, and then we're going to go to stats test and we go to t-test. And just a note over here, we did already learn about t-test. This was covered in our chapter 8 notes. So definitely something that you might want to look back at to refresh on using this. So going to t-test and entering your information in, you're going to get an output of our test statistic and then p, which is our p-value. So if a p-value is less than alpha, reject the null, and step 5 is going to be state the conclusion. So note, it says if the samples are small, it's less than or equal to 30, then we're going to construct a normal quantile plot and box plot to verify the differences come from a population with approximately normal distribution. You have to go back and look at section 6.5 again for all the steps that we need to go through. Right below this, we have constructing a confidence interval for matched pairs data or that dependent data with our graphing calculator. So the interval is exact when the population is normally distributed and approximately correct for non-normal populations, provided that the sample is large. So our confidence interval for mu sub d is given by, and we're going to go to stat, test, and t-interval, which again we saw back in chapter 7. And our calculator is going to give the lower bound and the upper bound. And then we have to look and see if 0 is within that interval. So we have some examples right below this. The first example starts at the bottom of page 7 but continues on to page 8. So it says an experiment was conducted to see how 6 randomly selected participants react to a stimulus. In one experiment, the participants must press a key on seeing a blue screen. Reaction times in seconds to press the key are measured. The same person is then tested with a red screen and reaction times are measured. The results are, and they also, it says the differences are approximately normally distributed. So with this, you're matched up, but you're matched up against yourself. So they're measuring you with a blue, and then they're measuring you again with red. So you notice we have our participants 1 through 6, the reaction time with blue and the reaction time with red. So in order to do this problem, we are going to have to construct our differences. But if you look at part A, it says, why are these considered matched pairs? And we kind of said this already, but it's because you are matched up with yourself. And they're measuring those reaction times for both of those colors and see if there's any difference between those two. And so it says for B, it also says in the study, the color that the student was first asked to react to was randomly selected. So it means that not everybody started with blue or started with red, it was randomly selected. And so this is because a lot of times it takes people a minute to kind of get used to a task, and then you get a little bit more comfortable. You start learning how this process is working. So this is to control any learning. And I'll put learning in quotes, but it just means any, like getting used to maybe pressing the scene, and you kind of go like, oh, I get the hang of this now, I'm going to press it now. And you get a little bit more used to it as time goes by. So with this, we do need to calculate the differences. So I'm going to go back to page 7, and I'm going to calculate these differences. For the differences, I am going to subtract, and again, that's what difference is. But I need to be consistent. So I'm going to do red minus blue. And so subtracting red minus blue for each of these participants, I get participant 1, negative 1.174. Participant 2, negative 0.074. Participant 3, negative 0.299. Then 0.135. Negative 0.229, and 0.083. These numbers all will need to go into L1 when we're going through the calculations. So again, you do not put in the reaction time for blue and red, you put in that difference that we just calculated by subtracting. So part C says, is reaction time to the blue stimulus different from the reaction time to the red stimulus at an alpha equals 0.01 level of significance? Test using the p-value method. So for this, we are going to have to come up with our null and our alternative. And so our null is going to be that those differences are equal to 0. There is no difference. So we're going to say mu sub d is equal to 0. And then it wants to say that the blue is different from the red. So this is going to be mu sub d is not equal to 0. So again, our differences are calculated at the bottom of page 7, and those need to go into L1. And then once we have those in, we can use t-test. On your graphing calculator, you're going to go to Stat, Edit, and first enter in all those values into L1. Double check to make sure those values are entered in correctly. From here, we're going to go to Stat, Test, go to T-Test, and for T-Test, you need to make sure that you change this to data. And so data should be pulling in from L1, frequency should be set equal to 1, and then your mu naught, you need to make sure that that is set equal to 0. You also need to check your alternative hypothesis, which is a not equals 2, so make sure you select not equals 2. And from here, you should get your p-value. From the graphing calculator, we get a p-value equal to 0.2466. And comparing this to alpha, we see that this is greater than alpha, which was given as 0.01. And so this means that we do not reject our null. So writing our conclusion, we are going to say there is not sufficient evidence at the alpha equals 0.05 level of significance to conclude that there is a difference in reaction time to the red and blue stimuli. So right below this, it does say to construct a 99% confidence interval for this, and it says interpret your results. This one's a little bit different because it did give us that confidence level. And so that means that in here, our C level is going to be 0.99. And so that means that each of these tails would be that 1% divided by 2. It's going to be 0.005. And 0.005, and this is our C level. On your graphing calculator, you should already have the values entered into L1 from the previous part. So this time we are just going to go to Stat, Test, and we're going to calculate our T interval. And with our T interval, we are using data. Our confidence level is 0.99, so make sure we have it set for that. And then rounding our lower and our upper bounds to 3 decimal places. From the graphing calculator, we get a lower bound of negative 0.379 and an upper bound of 0.193. So 0 is in this interval. So 0 is in interval. So this means that we do not reject H naught, which is what we saw up above in part C. So there's one last example here, and the example says, given in the table below are heights in inches of mothers and their firstborn daughters. Use a 0.05 significance level to test the claim that there is no difference in height between mothers and their firstborn daughters. Heights are normally distributed. So for this, again, this is matched pairs data, and the reason why is because if you select a mother, then you must select her firstborn daughter. Does not make sense to compare a mom to another firstborn daughter of another woman. So this is matched pairs. And so we do need to calculate that difference. I am going to subtract and say mom's height minus daughter's. And again, just make sure you're consistent through the whole problem. And so calculate that in just a second, but because this is matched pairs, you are going to have a null and alternative hypotheses with mu sub d. It does say different in there, so we know it's not equal to 0, and our null would be equal to 0. So now calculating those differences, we're going to subtract the mother's height minus the daughter's height, just like what we did on the previous problem. And so for the first one, we get negative 0.5. So take a moment and see if you can calculate those. So hopefully we got the same differences, and these differences all need to go into L1 on our calculator. And a good thing to note here is that the ones that are 0, where there was no difference between the mother's height and the firstborn daughter's height, need to also be entered in. So yes, you do need to put those zeros in as actual data values. So we're going to go to t-test on our calculator. Again, make sure you have your differences entered into L1 before you go to t-test. On the graphing calculator, we're going to go to Stat, Edit. First, enter in those values into L1, again, double checking to make sure that you have them entered in correctly. Then Stat, Test, T-Test. Make sure you have data selected, and mu naught should be equal to 0. And then your alternative hypothesis needs to be a not equals to, and then you should see your p-value on there, and make sure that you, from the graphing calculator, we get a p-value equal to 0.2013, which is greater than alpha, which was 0.05. And so because of this, we do not reject H naught. So our conclusion is going to be there is not sufficient evidence at the alpha equals 0.05 level of significance to conclude that the mean height between mothers and firstborn daughters is different.